In 1963, a very interesting object was found at Mount Palomar Observatory in San Diego, California. This object appeared to be fairly luminous. It was about a 13th magnitude star. But the interesting part of it was the spectrum of the star. It appeared that it had very strange spectral lines, and it didn't really match anything that we knew on Earth. And so it turned out that the spectral lines had shifted quite a bit towards the red end of the spectrum. And based on the rate of expansion of the universe, we now know that this object is about 2 billion light years away. So it's a faraway object, and it's extremely luminous, and it was stellar-like, and it was kept changing its light, so it was a variable star. This object was a mystery until 1980s, when we discovered the true nature of this object. It turned out that that object, and objects very much like it, were actually supermassive black holes that were active in the nuclei of faraway galaxies. Some of them turned out to be active, and this activity was pointed towards the Milky Way, and that's why they appear to be super bright. In some of these, we can even see spiral arms emanating from the nucleus of the galaxies. So these are a variety of quasars. A supermassive black hole in the core of a galaxy, it accretes a disk of material around it. This is called an accretion disk. This is mostly gas. And this gas, as it's falling in, it rotates at extremely high speed, and then it falls in. Some of the light is coming from collision between the particles, and most of the energy is coming out from matter trying to fall in, but it cannot fall in because it's small. So some of it gets blown away into jets from the north end and the south end of the magnetic lines. These jets are incredible. The amount of energy that is being produced is astronomical. That's a lot. And so what happens here is that the particles are being accelerated very close to the speed of light. And at the very end, they have something we call lobes. So these are the lobes. And from these lobes, there's also a fantastic amount of radio waves coming out. Some of these are not even visible except in the radio, so we call them radio galaxies. They have two lobes on either side of the galaxy. Here's an example of a nuclei of a galaxy at work. So there is the accretion disk, material is falling in. Some of it is not going in, but it's getting accelerated to the speed of light towards the north end and the south magnetic end of the black hole's rotation. If we on Earth happen to be in the line of this matter, if this matter is pointing towards us, then we see what we call a quasar. But these quasars are even extra luminous, so they have a special name. We call these quasars blazars. This is an example of a blazar. So as we can see, the jet could be pointing towards the Milky Way, and we see an extremely luminous object far away from the Milky Way galaxy, billions of light years away. Although most all major galaxies appear to have a supermassive black hole at their core, not all supermassive black holes are active, and not all of them are pointing their jet close enough to the Milky Way to be extra luminous.